Hello, everyone. Welcome to another video. Well, if this is your first time, still welcome. This is Leetcode 2360. Wow, longest cycle in a graph. This is a hard Leetcode question, but I think that today we can explore a very simple approach. It's been previously asked by Just Pay, Microsoft, and other companies. I'm sure Facebook, Google, so on and so forth have acted at different points in time. So you are given a directed graph of n nodes numbered from 0 to n minus 1, where each node has at most one outgoing edge. So we have a directed graph, right? And the graph is represented with a given zero index array, edges of size n, indicating that there is a directed edge from node I to the edges I. Right, okay. So if there's no outgoing node from the node, then edges I is equal to -1. Okay, cool. Return the length of the longest cycle in the graph. If no cycle exists, return -1. A cycle is a path that starts and ends at the same node. Okay, so we have an idea of what a cycle is, right? This is a cycle marked by the red arrows, right? So you can start from 3, go to 4, go to 2, and then come back to 3. So as the question is saying, a cycle is a path that starts and ends with the same node. And actually, this is the only cycle in example 1. So it's definitely the longest cycle. And here we have no cycles, right? So we move from actually, so 3 points to 1, 2 points to 3, and 2 points to 0, right? No one, there's no cycle. So there are many ways to solve this problem. You can use DFS, right, where you start at a certain node and explore all its neighbors, keep it in a visited array. And if you meet another node that has been visited, right, then that might be an indication I've previously explored that, or that there might be a cycle. You can use that one if you want DFS. And there are a few solutions here with DFS. Very, I think most of them are DFS solutions actually. Also you can use BFS, right? Breadth first search. And actually in our solution, I'm kind of going to use BFS. And I like this because it's Kahn's algorithm. That's how we want to solve this problem. So basically, we want to use Kant's algorithm. And if you previously seen Alien Dictionary, right, which is a lead code question, or course schedule two, and so on and so forth, right? Kant's algorithm, the BFS, or topological sorting can be very, very helpful, especially in finding um, cases where you have a directed acyclic graph, right? Perfect to use. Except this time we do have a cyclic graph, right? Or we assume that there is a cycle and want to find the longest cycle, right? So Kant's algorithm can still be very helpful because it works very well for directed edges. And we want to see how we can use Kant's algorithm to solve this problem. So basically, we want to go to the whiteboard, I think, at this point. So we have the example 1, right? And with Kant's algorithm, what we will do is we'll have a queue, right? Queue data structure that will keep in the elements with zero dependency. So basically, if you've seen the Kant's algorithm, it should be easy for it to see what I'm talking about. So basically, we have different nodes, and we are interested in those. Initially, we are interested in the ones with zero in degrees, right? So the in degrees is the number of dependencies you have, right? So dependencies is right dependencies, and probably my handwriting is not the best. However, right, like the elements with the zero dependencies, right, in your queue, you're going to take the elements with the zero dependencies and then put them in there first. And note that something which is a dependency is basically that you have an element pointing to that, right? So if you are in a cycle, right, you will always have something pointing to you because you see, for example, we have 3. If you remove the elements with zero dependencies, right, there'll still be now things that depend on 3. So 3 will always be in your um in your we'll always have a dependency, right? So we can use that to our advantage, knowing that if an element has a dependency, right, then we can enter with that element and loop through and find the longest cycle there. So basically, with this, let's try and solve the question using Kahn's algorithm, right? We have a queue, and I'm going to call it queue, and our queue will have the elements we've previously visited, right? So the elements with zero dependencies, right? And then we want a visited array. Oh my god, not to go with this, but basically, we want a visited array where we keep all the elements that have been visited, right? So initially we want to set the in degrees, right? The in degrees is the numbers of elements that are pointing towards you, right? So zero, this node has zero dependencies, right? No one is pointing to zero. Same for one, no one is pointing to one. And for three, you see we have three elements pointing to three. So we have three here. We have one element pointing to four, and we have just one element pointing to one. So what I want to do is, and the BFS will go. So if there's no cycle, right, the BFS will go through every element and then it will visit every element, and we wouldn't have a problem. So we remove the ones initially with the zero dependency. So can remove let's just for the sake of it, let's remove zero, right? So we remove this edge and then we put it in our queue. So you say zero, we've visited the node zero, right? Sorry, we've used the node zero, right? So we put zero first in there, and we also put this one also with what basically just before we move on, we've taken zero out, right? So the numbers of elements that depend on three now is what? One and four. So we have, instead of three, we reduce it to what? Two, right? You see where I'm going with this. So two, and this element also has a zero dependency. So we take this one out, right? And then which is one, right? Node one. And then we also reduce the dependencies was by one. So now, if we are done with processing an element, right, we want to say, okay, we visited that element. So if we visit that element, we say visited zero and we visited one. But we've actually seen that we've not visited three in this scenario, we've not visited four, and we've not visited two because they don't fit our criteria of what the elements with zero dependence. We've not processed them yet. So when we go through our visited array, and let's say we had the spaces for what two, right, will be false, the space for three also be false, space for four will be false. And now we can go through it and say, oh, okay, now this is the first time we are seeing two. We are going to our visited array. First time we are seeing two. When we see two, okay, cool. Now we've seen two. We know that if you've not previously visited it, then it has to be in a cycle. So then we try and find all two's neighbors. So we go from two and we say, okay, now two is visited. So now this will change into positive, for example, or true, right? And then we go to node 4, allows us to go to node 4. Okay, cool. So this becomes positive also. And then we're able to go to 3, right? That also becomes positive. And in while we are doing that, we are actually keeping the length of what, or the longest possible cycle we've seen so far. So basically, that's it. You use your Kahn's algorithm to remove those elements with zero dependencies, right? And then with everything else that'll be left, you know for sure that it's a cycle. So now we go through each and every one of them and find which of them is the longest cycle. So that should be it. Shouldn't be that difficult to code up, and we should go back to the coding section so that you can easily see how we do it in Java. So basically, if we look at the um, basically this one, the BFS will remove essentially every element, right? So there'll be nothing left. So there's no cycle. Okay, so now let's do that. Let's have so we have let's call an array of degrees, right? To keep the count of the degrees at each point. And actually, I want to call this n because we'll use the edges of length a bit more. So int n is equal to edges of length, right? And then degrees is as long as what edges is. So we want to go through initially our degrees is all going to be zero, right? Everyone is going to be zero. And then we want to update in degrees, right? Actually, let me call it in degrees so that it's just easier for you guys to see. So in degrees or dependencies, right? The number of dependencies we have. So that is us going through every node in the edges. Actually, so k is less than n and k plus plus, right? And so into u, right? Let's call our u our source. Actually, let me just change the name. Let's call it source. If our source is going to be k, right? As it's given us, but our destination is going to be what edges k. Basically, that's like so three threes are zero in there, so it shows us from 0 to 3, for example. That's it. So if our destination is not -1, right? Because -1 is when we have like this, it's not pointing to any element. Right? So if our destination is not -1, what we want to do is then update in degrees. Right? So in degrees of the destination, right? We increase it by 1, basically. So that's what we want to keep an update of the in degrees. And this is where I want to use Kahn's topological sorting, basically, where we have a Q data structure of the integer. I have Q new linked list, and then we add elements with 0 dependency, right? So for int k is equal to 0, and k is less than n, and k blah blah. So if in degrees, you are looking through in degrees. If in degrees k is equal to what? 0, then want to add that element k, right, or that node k to our q. So we'll say q dot add k, right? So this should give us a good head start for the elements. And now we need what a Boolean array of visited, right? The number of elements that we visited. So we need n, and now we can do BFS or topological sorting, right? So basically, what was used after topological sorting, we just have cycles left, basically. So what I want to do is say that while the queue is empty, sorry, while it's not empty, we want to run our BFS. So we'll say the current peak, sorry, it's queue, right? Queue dot pull the first element, and then basically we pull the next element, but the next element we can get it from what? Edges current, right? So whatever current is pointing to in our edges. Now we want to say we've already been to current, so we say visited current should be equal to true. Now if our next is not -1, then if our next is not -1, then we have in degrees to update, right? We are going to update, so we'll reduce everyone who depends on current, right? By here's what in degrees by what? By 1. We reduce it by 1. And if so, basically, actually, so in degrees, next, right, should be negative. We reduce by 1, right? And now, if that value goes to 0, then we want to add it to our what q. In degree next, if it's equal to 0, then I want to add it to our q. So add q, sorry, add next to our q, right? So just keep doing our BFS basically. And then we'll do the same thing for the elements with 0 dependencies, right? So now we know that those with non-zero dependencies, right? If I loop terminates are in a cycle. So if they're in a cycle, then we have to look for our max. So initially, we want to set our max to what, -1, and we're going to set it to -1 because normally you'd want it to be at 0 or something like that, right? So by -1, because if no cycles exist, we want to return -1. So basically, if the max goes through the code we are coming to write at the end, then there's no change. Then it should return -1, right? That's basically what it is. So we're going to say, and I'm going to loop through the visited array, right? So for int k is 0 and k is less than n and k plus plus, right? If if we've not visited that point, right, then what we want to do is to say, okay, if we've not visited that point, now we are in we have an element in a possible cycle. So what we want to do is to get the length of that cycle, right? So we have our count. Our count is just representing the first element we've seen, right? And then we have our next. Our next element should be what? Whatever edges of k, right? So whatever k is pointing to in edges, it will be our next. That's what we want to do. I want to also now mark um, the visited k to be true, right? I want to mark it to be true, and now we'll move on, and then we'll have a while loop. So we'll loop and basically say we will go through all the connected points, and if you are able to return to 3, then we know that for sure that was a cycle, right? And the cycle has ended, right? So whilst we are looping through what the cycle is, we are updating our visited, and we are updating our visited with the nodes that we've just seen, and also we are increasing the count. But our loop is that if next is not equal to k, right? It's not equal to our start actually, or k, right, where it starts, then we can keep doing um going through the cycle, right? So we'll see we want to increase count by 1, and then we will say our new next is what actually, so next is equal to what? Okay, let me just write int new next so that you guys can see the difference. Right? So our new next will be what? The edges next, right? And now next is equal to our new next. Um, and also basically we visited next. So before we change the next, we want to say that we visited next. So visited at next, we will set it to true, right? Basically, this should loop and go through the whole cycle, and then we will update our marks based on the counts you have, right? So math on marks, count, and then you have marks in there. And if this goes through, we want to return marks, yeah, right? So basically, this is it. Probably a few bugs. Let's go through. Okay, cool. So we have an index out of bounds. Here. Oh, I meant if destination is not equal to -1, right? Then increase it. Yeah, so passes these two test cases, and you see, we reach 98% of Java users. So basically, this is very easy to do. And what is the runtime, right? And let's go through that together. Basically, we are doing a BFS, and we are going to touch each node at least once, right, all through the code. So at the worst case scenario, this our while loop will touch every single element. Worst case, this also touches every single element, right? So you have O of n basically in total will be our runtime. So this can be done in O of one n time. And that's basically it, guys. I hope this video was helpful. If you like it, please do subscribe. And hey, sorry, yeah, subscribe, like, and I'll see you on the next one. Thank you.